All right, so we're going to talk about factors that are affecting absorption and reflection of insolation. Just remember, what is insolation? Radiation from the sun, exactly. Okay, so when we're talking about that, it's like how well is that UV radiation going to be absorbed and how well is it going to be reflected, right? So the first thing you're going to talk about is that angle of incidence. So this should be a review for you, right? We've talked about the altitude of the sun when we did all of the apparent motion diagrams, right? The angles at which the sun comes down. If it's up higher, it's going to be stronger UV radiation. So if it's at your zenith, you have to really be careful with using the sunscreen. If it's down lower, not as much, right? Then the surface characteristics, right? We learned about texture and color, right? If it is a rough texture and a dark color, it's going to be absorbing more than if it is a smooth texture and a light color. All right, then you have change of state and transpiration. So change of state is when you go from a solid, a liquid to a gas, or a gas, a liquid to a solid, solid to a gas to a solid, right? And transpiration is basically evaporation for plants, right? You guys learned that last year. All right, what's too far? Change of state is when you go from a solid to a liquid to a gas to a liquid to a solid, when you're changing the physical state. Transpiration is basically evaporation of water from plants. Okay, all of these factors are going to affect it in one way or another. Okay, so you remember this when we did the lab. You just did the lab, right? If you have water, it has a higher specific heat, right? And therefore, it's going to be more transparent, freely flowing, which allows convection to occur, right? Which means that it takes that sun energy into the water, gets converted to potential energy during that change of state called evaporation. Okay? And therefore, there's less energy inside of the water to increase the temperature because liquid water specific heat capacity is 4.18 joules for every 1 gram. Right? So it's going to take water a longer time to heat up in comparison to pretty much everything else. Right? This should all be a review for you because we just did it in the lab and we just did it last chapter. Okay? The fact that it's see-through allows that UV radiation to really get down in there, but it never gets a chance to actually heat up the water as it goes through because it's moving so far down so quickly. So this is just like it is from the lab. When is your lab due, guys? Friday, very good. Guys at home, you with me?
Miss Gonzalez?
Okay, good. What's up?
I was just wondering for like lab 13, are you gonna be having extra help on Thursday?
Yes.
Okay, thank you.
No problem. we've talked about it before, right? A greenhouse is basically a very large glass area. It looks like a little house, right? That allows that harmful UV radiation in because it's short-wave, right? And the shorter the wavelength, the more likely it can penetrate through things, right? Once it gets absorbed by whatever's inside the earth of the greenhouse, right, it gets turned into long wave, what kind of radiation? What kind of radiation does it get turned into, guys? Ooh, infrared radiation. Okay? And the greenhouse does not let it leave. So if you're talking about a greenhouse effect, you're talking about how that radiation ends up getting trapped and coming back to the earth. So it gets trapped by those greenhouse gases, which are carbon dioxide, methane, and water vapor, are the three most popular ones. Okay? Sometimes it gets absorbed by the atmosphere and then thrown back down to earth. Right? So that long infrared radiation that gets thrown back out by the earth hits those greenhouse gases and reflects back down. Right? That's why it's called surface radiation, because when that UV radiation comes in, it gets absorbed by the surface, gets changed to long wave infrared radiation, which does not penetrate as well as the short wavelengths do, okay, and cannot get through those greenhouse gases. Sometimes they hit those greenhouse gases and come back down, rewarming the earth. Why did that just happen? All right. On the next slide, you will see exactly what I'm talking about. And you've seen this picture a ton, or a version of a picture like this a ton, because I actually took it from a textbook that I think you guys used in 8th grade. This picture here, okay, where you can see the blue shortwave radiation coming from the sun, right? It gets heated into the ground. It gets absorbed by the ground. It gets absorbed by whatever's inside of the greenhouse. Then it gets converted into longer waves. And you see how it's being bounced back? Some of them, oops, hold on. They're being bounced back by the glass. It's acting as if it was those greenhouse gases. The glass is not made up of greenhouse gases. I kind of have to point that out to you, okay? But it acts like the greenhouse gases, so that the inside here, this is how you get your nice pretty flowers for in the middle of winter if you want a specific flower that only grows during the spring for your wedding. They get grown in a greenhouse, okay? If you want certain vegetables, like right now I think, what is it, tomatoes are out of season right now? Tomatoes and peppers are out of season, so they get grown in a greenhouse or they get grown somewhere else, okay, which is why they're so expensive, because they have to be shipped here, because they're more of a summer vegetable. Question?
So if there's like more, because of a lot of radiation inside of the greenhouse, right? Would any of it ever sound kicked out of the greenhouse, like through the box?
So some of it does get, the question was, does any of the infrared radiation ever leave, basically, right? So some of it does leave. Some of it hits the glass and comes back down, gets, reabsorbed, and then goes back out. It could be like a ping pong ball, or bing, 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 and then eventually leaves. It just depends on if it happens to hit that one specific space in between the molecules that allows it to leave. So the problem is that if you have more greenhouse gases, the less likely that infrared radiation can leave. And then you get into a situation like Venus, where it's so hot there, right? So since it's so super hot, it's because of those greenhouse gases trapping it in, and then they just keep re-radiating over and over again. They can't escape. Right now, we're not up to that yet, right? So that infrared radiation gets absorbed by carbon dioxide, the CO2, water vapor, and methane. That's those three there, CO2, H2O, and CH4. Okay? So if that infrared radiation hits any of those, in our atmosphere, then they get sent back down to Earth and rewarm the Earth a little bit more, which doesn't seem like a lot, right? Because remember, there is a natural greenhouse effect that has been taking place as well. But we've just exasperated it. We've just made it way worse, right? Because we've added more carbon dioxide into the air because we breathe out carbon dioxide, right? We've added more methane. I don't know why it keeps doing that. Okay, we've added more methane because of different things that we are doing, right? We're also mass producing, whatchamacallit? We're mass producing cows, and cows are actually the #1 producer of methane because methane is a fart, basically.
I was going to say, like, don't cow farts, like, methane.
Right, cow farts are the #1 producer of methane, but that's the natural producer. So remember, this will happen naturally, but since we have so many more humans, you have so much more milk that needs to be consumed and so much more food that needs to be consumed that you have to breed more cows in order to produce those, which means that you have to feed them, which means that they have to eat more, which then they fart more, which leads to more methane. Yeah. So remember how I said, right, there's a natural greenhouse effect that is happening on its own. It will happen on Earth no matter what, where there's a gentle heating. Then we show up and all of a sudden there's a spike, okay? When you are looking at this, you can see that solar radiation comes in, some of it does escape, so like you were saying, some of it does escape, some of it hits those greenhouse gases and comes back down. But our enhanced greenhouse effect, the problem with humans is that we've made the situation worse, right? The sun comes in and there's more of it that gets bounced down than gets let go. That's why this is a lot thinner, right? So some does escape, but most of it is staying in. All right, so here are some natural producers of greenhouse gases. So again, this is natural. On its own, will happen without humans. Okay? If you'd like to take a picture of this, you can. Connor, do you want me to pull that down so you don't get the glare?
No, it's fine.
Okay. Okay, so natural producers of greenhouse gases are going to be volcanoes. Volcanoes are going to be a very large producer of greenhouse gases because when they explode, it's only when they explode or if they erupt a little bit. Like Mount Etna just erupted last week, okay? The Hawaiian one was, what, 2-3 years ago now? And they were worried about the aftermath of it, okay? When you are looking at volcanoes, the lava is not what you have to worry about. The lava is very slowly moving. Yes, it's extremely hot, but that's not what you have to worry about being near a volcanic eruption. It's that ash, okay? That ash contains sulfur dioxide, which would kill me instantly. But it also, the ash can actually harden like concrete when you breathe it in on your lungs and you get like cement lung and die. Basically, you're drowning on land. Okay, it's really scary. And also that ash, it also throws rocks and different minerals. Okay, it gets very heavy. It's not like when it snows out like outside right now, where it's nice and snaky. It's not a big deal. The ash is so much heavier than anything else that when it lands on roofs, when there was the eruption in Italy, long time ago, right? You guys remember what that's called? Pompeii, yeah. So when the volcano in Pompeii erupted, okay, one of the major things that happened was people ran inside their houses thinking, I'll be protected by everything that's in there. But the ash fell on their roofs, which then collapsed their roofs. Okay? And so ash is way heavier. The other thing is, too, is that it can create almost a giant cloud that blocks the sun, creating underneath it a nuclear winter because it stops allowing the sunlight to penetrate through. Okay? So it can go either way, right? Then you have this aerosol layer that has happened before. You also have us down here. Human activity just is making it worse, right? You have biomass burning, ocean and wetlands when they become other things, when they break down, they can create gases that go up into the air. But again, these down here, except for the human activity ones, are actually natural producers. Okay? So there are some natural producers, right? We've just made it worse. All right? So here we have the layers of the Earth. You see how the ozone layer that's out here actually absorbs that harmful UV radiation. That was one of your questions, I believe, on your exam, right? Should know by now, the sun gives off ultraviolet rays. The main purpose of the ozone layer is to protect us from those harmful UV rays. Without the ozone layer, it becomes a big problem. Okay? These images here range from, I think this one over here said it's 2000, and I think down here it's 2004. Right? So it's different dates, but this big hole here is that hole in the ozone layer. Since they figured it out, we have been able to slow the hole from growing. Because like I was telling you guys, remember, so 1990 to 2014, okay? Like I was telling you guys, I believe yesterday, right? You guys are smarter than your great-grandparents were. And what do I mean by that is you're more educated, okay? You're more educated about recycling. You're more educated about how to do things differently. Whereas your great-grandparents would just take every bottle and throw it out. Or, actually, sometimes they were smarter because you would have glass bottles that you would have be refilled. So like your milk was refilled into a glass bottle, but it's not as cost effective. So they were putting the cost on things that was actually ended up hurting the ozone layer later or the recycling later. But you guys have learned from their mistakes, right? You guys know the difference between a blue bin and a regular garbage pail, right? And in some places, it's a blue bin, a green bin, and then a garbage pail, right? So garbage is stuff that cannot be compost, it can't be, it's non-compostable stuff. Not, the green bin is usually for cardboard, and then the blue bin is for all your recyclables, like your plastics and stuff, right? You ask your grandparents that, maybe even if your great-grandparents still around, that didn't exist. There was one garbage. That was it. So you guys have learned a lot more than they have. This is what I want you guys to work on for the next 10 minutes or so. Okay? This is your homework if you do not finish it, and I want you guys to justify your answers like we did. Okay? If you guys have any, I'm going to post it right now. Sure.